Hello everyone. So here's another problem on Thevenin's theorem. So this problem is asking you to find the Thevenin's equivalent circuit for the given circuit, given network, right? So it has a voltage source, it has a current source, right? This is a voltage source, you have a current source, which is delivering constant 1 amp current, and you have 4 resistors. And it's asking you to find the Thevenin's equivalent circuit. And remember, just a quick reminder, so you can convert this whole complex circuit with just a single voltage source with a series resistor. And that's called the Thevenin's equivalent circuit. So let's get started. And if you remember the trick, so there's no load resistor here, right? There's no load resistor placed here. Load resistor is already removed, and which is good. So whatever resistance you find from here, right, or whatever voltage you see from here is the Thevenin's voltage, right? So somehow you have to find out the voltage, right, from this side. And now you can do that in couple different ways, right? So to find the voltage across this 10 ohm resistor, which is the Thevenin's equivalent voltage, you can either use Kirchhoff's laws, let's say nodal analysis, right, or KVL, right, loop law, or just use the source conversion, right? The source conversion that I mentioned in the previous video. So source conversion will be a lot easier actually, right, to reduce the circuit. So let's get started. So as you can see, in source conversion, what does source conversion say? Source conversion says any voltage source with a series resistor is equivalent to a current source with the same series resistor in parallel. So this can be written as this, right? Can be written as a current source, right? So I keep doing this source conversion, is equivalent to a current source, right? The same series resistor, which is 20 ohms, and you have 5 ohms already, right? And you have this current source 1 amp, and you have this, you have that. Okay. So this is your 20 ohms, but how much will be the current? This current, right? This current will be based on the source conversion rule. It's going to be 10 volts divided by 20 ohms, right? It's half amp, right? And this is 1 amp, and this is the 5 ohms, same 5 ohm, and this is the 6 ohm, and this is 10 ohms. So remember, somehow you will have to find out the voltage across the 10 ohm, and that's your equivalent Thevenin's voltage. That's what we're doing. Now, again, keep doing the source conversion, right? Just keep trying to keep simplifying the circuit. Now I can see this. What is the equivalent circuit of that? Equivalent resistance of this 20 ohms and 5 ohms, and they are in parallel. So its equivalent is 1 over 20 plus 1 over 5, right? And that's going to be 4 ohms, right? If you do that, it's going to give you 4 ohms. So this can be replaced by 4 ohm. And also, one more thing is this. Look at the current sources. This is a current source which is delivering now half amp, right? This is a current source 1 amp in the same direction. So this whole thing now can be reduced by this circuit, right? This whole circuit, this from here to here, is a single current source. You can simply add 1 amp and half amp because they are in the same direction with a 4 ohms of resistor, like that. And this is the rest of the circuit, right? So this is now 4 ohms. Now this is 1.5 amp, right? 1 amp and 1 amp and half amp, 0.5. 1.5 because they are in the same direction. If they were in opposite direction, then you have to subtract it, right? It depends on the situation. Okay, 10 ohm. Remember, our main objective here is to somehow figure out the voltage here for somehow, right? Okay, now I can see now again this again can be reduced to using source conversion. It can be represented by a voltage source, right, with a series resistor, same say 4 ohm series resistor, and you have this, you have that. So we're almost done. So you have 6 ohm, 10 ohm, right? And now how much will be the voltage? Voltage will be the 1.5 times 4. So 6, this is equivalent to 6 volts, right? Now these two are in series, so it's a 10 ohm resistor, right? So 10 ohm resistor. So this finally it becomes a 6 volts, right? And you have a 10 ohm and 10 ohm. And you just need to figure out the voltage here. So it's a 10 ohm, it's a 10 ohm, and what's the voltage? 6 volts, right? And that's it. We're almost done. So let me erase that. So keep doing the source conversion unless you get a single voltage source with a single series resistor. Just keep doing this source conversion, right? So source conversion is a very useful idea. So finally, almost. So now again, I'm going to do one more source conversion. So this is a source conversion between 6 volt and 6 ohm. Can be written as a current in this direction with a same parallel resistor, right, which is 10 ohm, and you have 10 ohm, remember, like that, right? So I know how much will be the current. This current will be 6 volts divided by 10, right? 0.6 volts. So it's a no, I'm sorry, 0.6 amp at 10. Now the equivalent circuit of this 10 ohms and 10 ohms is what? Is 5 ohm in parallel, like that, right? So it's a 0.6 amp, it's a 5 amp, which is the equivalent, the parallel combination between 10 ohms and 10 ohms, 5 amp. Now we're almost done, right? So now finally we can convert to a voltage source. We got one current source, 0.6 amp of current, in parallel with 5 ohm resistor. Now this is from the source conversion, this is equivalent to a voltage source with the same series resistor, which is 5 ohm, right, and whose voltage is now 0.6 times 5, right? Yeah, it is 3 volts, and this is your 5 ohm. Okay, that's it. So you have automatically converted into a Thevenin's resistance. So this is your Thevenin's resistance now. Your Thevenin's resistance is 3 volts, and your Thevenin's voltage, equivalent voltage is 3 volts, and your Thevenin's equivalent resistance is 5 ohm. So the technique is just, if you have circuit like that, right, so just keep doing the source conversion until you get a single voltage source and a single resistor in series, and that resistor is going to be your Thevenin's resistance, and that single voltage source is going to be your Thevenin's voltage. That's it.